Hello dear students, greetings of the day. Today I, Mohammad Zishan, will take the very first lecture of Geography chapter 5, which is Landforms of the Earth. Dear students, this is one of the very important chapter of Geography, Landforms of the Earth. You need to understand first of all what is the meaning of landform. So the type of land means the form of land, how the configuration of land is, what is the shape of the land. Okay, that is called landform. The form of land, like whether the land is a mountain or a land is a plain or a plateau, how what is the form and configuration, shape and size of the land. Okay, so basically form, shape, configuration of solid part of earth surface, example mountain, plateaus, plain, etc., are called landforms. So in this chapter we will be studying about three main or major landforms, which is mountain, plateau, plain, etc. And other than these three important landforms, we will be also studying uh, about various other landforms which are created by the depositional and erosional work of uh, air or wind and river, glaciers like gorge, canyon, or moraines, or meanders, I-shaped valley, V-shaped valley, or iceberg, or various other types of landforms that we will also study, but not here. We will study, or we will take these things which are not in the syllabus of class 9th geography, but still you need to know. Okay, you should know about these types of landforms too, and we will be studying about these type of landforms in next videos. After completing this chapter, we will stick to the book, and after completing the book portion, 2 or 3 lectures I will make to explain you about these types of landforms also. Now, when we look around, we find flat surface, we find curved surface of the earth, we find very highly elevated land, we find depressions also. So why there is a difference in the shape of the surface of the earth? Why the surface of the earth, the shape of the surface of the earth is not same everywhere? Why it is not plane everywhere? Why the surface of the earth is elevated, depressed, high, low in height? Okay, and why there are mountains, plains, plateaus? Why we are not having flat land all over the world? This question we will be taking into account. Now, what we will study in this chapter, we will study that what are landforms and how these landforms are created, or how these landforms are formed. Okay, the causes of the formation of these landforms. Now, we cannot form anything without applying force, or we cannot you can say move anything. Like suppose, in order to move this marker on board, I need to apply force on it. Okay, so which is the driving force for making this landforms? How, what is the cause for the making of the landforms, and what is the driving force for that? So we are having 3 causes which are given in your book. First is plate tectonic, second is uplift and submergence, and exogenic forces. Okay, so these plate tectonic and uplift and submergence falls under endogenic forces, right? The forces which are responsible for making landforms over on the surface of the earth can be categorized into 2 types: endogenic and exogenic. Endogenic forces are the forces which are generated uh, inside the earth, or the internal forces of the earth are called endogenic forces. and the forces which work on the surface of the earth, which are generated outside the earth, in earth's atmosphere. Okay, these are the external forces, okay, and called exogenic forces. So endo means something which is from inside, exo means something which is from outside. So the forces which are originating from inside of the earth are called endogenic forces, okay, and the forces which are outside, okay, this is the surface. Suppose here I am standing, this is the surface, right? So here the forces which apply like wind, like glaciers or rivers, things which apply here outside, okay, these are called exogenic forces. Which forces? Exogenic forces. Exogenic forces, these are working outside the earth surface, okay, and the forces which are generated from inside, which are applying force from inside, okay, these forces are called endogenic forces. So these are endogenic forces, these are exogenic forces. Now endogenic forces also work in two ways. The force which is applied upside is called the Epierogenic force, right? The force which is here inside, which is getting generated from inside, works in two ways. One is, one force works upside and another works on a tangent to the surface of the earth or horizontally, right? Means you can say there are two directions. The endogenic forces works in two directions, upper direction or vertical direction and horizontal direction. Vertical, when the forces are applied in vertical direction, then the upliftment of a big landmass takes place, okay, which forms the continents. Like we are having continents, 7 continents are there. So it is said that this landmass was uplifted by the forces which were generated inside the earth. These forces applied pressure upside and these land masses were generated, you can say, okay. So those forces are called Epierogenic forces. Epierogenic forces. Epiero means continent, and the forces which are responsible for the formation of continents are called Epierogenic forces. Right? These forces forms continents, even block mountains, rift valleys, right, and planes. Then second is when this force is applied horizontally, right? When force is applied horizontally, then folding or faulting takes place, okay. Folding and faulting takes place. Now what is folding and faulting? That also I will teach you. I will teach these things in plate tectonics in detail, right? Just I am giving you an overview of these things. After giving overview, I will be telling each and everything in detail. I will be explaining how all these things takes place, okay. So here in orogenic forces, the tectonic plates move towards each other, they collide with each other, right? When they move towards each other in this manner, that is called horizontal direction, right? So in that direction, what happens? Crumbling of land surface takes place and the fold mountains are created, right? So that we will study. Then exogenic forces are the forces which are applying outside. I have already told you external forces. Okay, in this forces are responsible for the erosion of already created landform. Like mountains are there. Okay, so mountains are created by the endogenic forces. Once a mountain is created, right? then what happens, the elevated land is leveled down by some erosional agents like air, like we can say glaciers and even rivers, wind and glaciers, they keep cutting these land masses and try to bring it towards a level ground. Okay, so it is like, suppose if because of the endogenic force, if one mountain is created like this. Okay, now what will happen after this? Weathering will take place. Weathering will take place, and because of weathering, these rocks will get disintegrated, the material inside the rocks will be loosed, right? And after that, the agents of erosion, okay, like suppose wind, if wind is blowing like this in this direction, this way, or you can say here, right? So it will start eroding this, and the mountain will become like this, and after 1,000 years like this, then more years like this, then time will come when this will this mountain will become a landform like this. Okay, means earlier it was this much high, it was created because of the endogenic force, right? And afterwards, because of the exogenic forces, okay, because of the winds or rivers or glaciers, erosion took place, and because of erosion it get completely eroded, and this material, this entire material which was eroded, this material was deposited somewhere in some depression. Suppose it was a depression, so in this entire material was deposited. So here erosion is taking place, and here deposition is taking place. Rivers or wind do erosion of this, and the eroded material is transported by river or air or glacier and is deposited in some depressions on the earth's surface. Okay, so likewise this landform is getting changed, the form of this land is getting changed from highly elevated to a leveled ground. Okay, so this we are going to study in detail. Now let me check video first. So, dear students, the cause which is given here, causes of the formation of this landform, first is plate tectonic. So, what is plate tectonic? We have already studied about the interior of the earth in previous chapters. If you remember, I have taught you that, okay, the center of the earth is core, and then we are having another layer which is mantle, and then we are having crust. Okay, so this crust is having lithosphere. Lithosphere means that sphere of earth which is hard, the surface of the earth which is hard. Okay, that is called lithosphere. Lith means stone, right? So that stony or hard surface of the earth on which we people stand, or uh, which gives us a platform to stand or to live, okay, that sphere is called lithosphere. It extend from this earth surface, from this very this, on the thing or the land on which I am standing, from there to deep inside 100 to 200 kilometer inside earth. Okay, so till there we are having lithosphere, right? Now that lithosphere is floating on asthenosphere. Here I have shown you This is crust, this is mantle, this is core. These things we have already studied. Okay. Now this this crust, this crust of the earth, it is a solid, right? It is in solid form, and it keep floating on this red one portion, which is called asthenosphere. What? Asthenosphere. Right here. Asthenosphere. Now, what is this asthenosphere is? This asthenosphere is a sphere of earth where rocks are found in semi-molten form. Which form? In semi-molten form. Okay. Now, on this asthenosphere, the crust, okay, the outermost layer of the earth keep floating, and this crust is not joined all together. Okay, this entire crust, suppose if we are having, this is suppose on a flat page we are having entire world. Okay, right? So this can be divided into, you can say, this one, Pacific belt, North American belt, South American belt, Antarctic belt, Eurasian belt, African belt, Indo-Australian belt. Okay, one, two, two, three, four, five, six, and seven. I am trying to show you, I am trying to tell you that, okay, the outer surface of the earth, which is also called the crust, okay, that crust is that crust can be divided into, you can say, seven cracks. Okay, major cracks on that crust is not, you can say, it is not completely a one crust, or it is having cracks. Okay, the crust is cracked, and it is cracked majorly at the 7 points. Okay, right? So those crack slabs of crust, or those crack plates of the earth, are called tectonic plates or plate tectonics. Okay, these are, what is plate? Plate means a slab. Okay, like we are having slab in our home. Okay, slab in our home is there, on which or you can say any slab. Okay, so that is a hard or solid slab, okay, which is formed by the earth crust. Okay, and that is called plate tectonic. So that slab is formed because of the cracks generated on the earth crust, and there are seven major cracks, you can say, or some cracks divide the entire earth crust into seven major tectonic plates, right? These major tectonic plates keep moving or keep floating on asthenosphere, right? This is the hard surface, and this hard surface is moving on this asthenosphere, which is in semi-molten form. Okay, now what are these uh, seven major plates? The first plate is, the name of the first plate is, let me write here, the name of the first tectonic plate is Pacific plate, which is found in Pacific Ocean. We have studied that, okay, there is a Pacific ring of fire. Okay, Pacific ring of fire means the Pacific Ocean, starting from, you can say, North and South America to to the boundaries of uh, Europe, Asia, right? So Pacific Ocean is in circular form, right? So that on that we find areas on the coast of North America, South America, and in Europe and Asia, where volcanoes takes place and earthquakes takes place. Okay, so that region is called the Pacific Rim or Pacific Ring of Fire. Okay, so means that region is having faults. One plate is there. Okay, one division of earth crust is that. Okay, this is the one division of earth crust, right? Then that second one is North American plate. Third is South American plate, and fourth is Eurasian plate. Sorry, uh, then sorry for writing. Then fifth one is African plate. Sixth one is Indo Australian plate or India Australia plate, and seventh one is Antarctic plate. Okay, this one plate, Pacific plate, and Indo African plate. These plates, this one is named after ocean, Pacific Ocean, and this one plate is named on the name of a country, India and Australia. Okay, Indo India, Australia, and New Zealand plate, we also call it Indo Australian plate also, it is said. Okay, rest of the plates, North American plate, South American plate, Eurasian plate, Europe plus Asia, okay, and African plate and Antarctica plate or Antarctic plate. These plates are named on the name of continents. So we can say that each continent is forming or having its own tectonic plate, like North America, South America. Okay, and then Europe and Asia. Uh, uh, these both continents are not separated by the seas. Okay, they are interlocked, you can say. So for that one tectonic plate is the Eurasian tectonic plate, and then we are having African tectonic plate, and then we are having a tectonic plate which is named on the name of a country, our country, India Australia plate or Indo Australian plate, and seventh one is Antarctic plate. So you can remember these 2, 3, 4, 5, and 7 by the name of the continents, and sixth and seventh one, Pacific and Indo, that you can remember on the name of ocean as well as our country. So this entire crust is divided into 7 parts, you can say. Okay, and these parts keep moving towards each other. Like suppose this is North America, this is South America. Okay, so they can move towards each other. This is African plate, this is Eurasian plate. Okay, so it can also move towards each other, right? So they can move towards each other or they can move away from each other, right? So when the tectonic plates move towards each other, okay, like they are moving in this direction, right? So this is called converging of tectonic plates or convergent motion, converging of tectonic plates. Okay, and if the tectonic plates are moving away, one in this direction and another in this direction, this is suppose T1, this is T2, this is also T1 and T2, right? So this is called divergent or divergent motion or diverging. Okay, so when converging takes place, then what happened? The earth's surface get crumbled like this. Okay, and folding takes place, right? Like suppose if there is one tectonic plate, this is this is a Eurasian tectonic plate and this is African tectonic plate, and it is moving towards each other like this. Okay, then what will happen? The land surface will be crumbled. Okay, and folding will takes place like this. Okay, so in that type of movement, what happens? Fold mountains are created, and when the tectonic plates moves away from each other, then what will happen? Cracks will be generated. Okay, crack may be generated during folding also. Okay, because tectonic plates either move towards each other, either move away from each other, right, or they slide past each other. Okay, if two tectonic plates, this is T1 and this is T2, they are sliding past each other, then what will happen? Major earthquakes will take place, right? Destructions will take place. Okay, and if they are moving towards each other also, then also earthquake may take place. Okay, and you can say folding will take place, mountains will be created. And when they are moving away from each other, then what will happen? Then faulting will take place. Okay, faults will be created, generated, and then the force, okay, the vertical force will be applied from earth, endogenic force, and the land may be even raised, right, upside, and because of the high amount of material or high amount of materials or layers of rocks, that can be subside also, sink also, that we will study, okay, afterwards. Just let me tell you these things. So here these are the 7 tectonic plates. These tectonic plates keep moving on this asthenosphere. Now question comes कि why they keep moving, why they keep floating, right? Which is the force which is causing this movement of the tectonic plates on asthenosphere, and why this asthenosphere is in semi-molten form. Okay, now see, we have already studied about the interior of the earth. Okay, we have studied that okay, inside earth temperature is very high. And why temperature is very high? Why inside earth there is heat? There is a reason for that. Okay, so the heat inside the earth comes because of two reasons. One is primordial reason, primordial heat is there. Another is radioactive heat. Radioactivity, okay. Radioactivity and primordial. Because of radiations which is taking place, radiations which comes out from radioactive materials or decay of radioactive materials inside the earth, and the primordial heat. Now what is the meaning of primordial heat? Why we, what we are studying? We are studying that we say that inside earth temperature is very high, around 6 to 9,000 degrees Celsius temperature is there in the core of the earth. Around 3 to 4,000 degree temperature is there in mantle, right, degree Celsius. So why the temperature inside the earth is too high? What is the reason for that? Okay, that thing we are studying. So when the Big Bang took place, when this entire universe was created, our solar system was created, it is said that, it is postulated that okay, there was a very hot uh, uh, gases, okay, a very large hot mass of gases was there, okay, and that mass of gases was spiraling all around like this. It is said that there was a nebula, you can say, according to nebular theory also, or so many other theories also, it is said that the material by which earth is created was actually burning at the time. Okay, it was, something was burning or blowing very highly. Okay, there was a nebula you can say, hot mass of gases was there. Okay, now these gases were moving in this, spiraling all around, okay, this way, getting or not? So during that movement only, this these masses were distributed by sprinkling in this manner. One is here, another here, another here, okay, and our planet and sun was created, okay. The remaining portion came to be called as sun, and the planets were also generated, okay. Now, whether according to this nebular hypothesis or another hypothesis, whichever hypothesis we take or whichever theory we take, okay, in every theory there is a mass of hot gases, okay, by which various planets were being formed. So when one mass of this air, mass of gases was sprinkled out this way, suppose this is earth, okay. So what happens, it keep rotating in universe, right, and the heat which was on the surface, right, was lost in that process, and the outer surface gradually became the outer surface cooled down with the passage of time, okay, right. Like suppose if you are having a iron ball, okay, just vomit, okay, in fire, and afterwards, after taking it out from fire, then pour some water on it, okay. So what you will find that the outer surface has cooled down, getting or not, outer surface has cooled down, but the things, the metal inside, okay, or at the center, that ball is actually having very high temperature, okay, getting or not, and it will take time to lose that temperature, right. If you are able to check the temperature of that ball at the surface and inside, then you will find that, okay, the surface has cooled down, but still inside there is a temperature is very high inside at the center of the ball or in the core of the ball. So in that manner only we are having preserved heat, okay. So the heat which was at the surface has been lost, okay, and this surface has cooled down where now life exists, but still inside, okay, we are having that heat, okay, which is left, right, from the time when the earth was created, that is called primordial heat, okay. And second thing is radioactivity. In the core of the earth we are having knife, okay, nickel and iron, and some other radioactive materials are there, okay. So these radioactive materials keep decaying, and they in the decaying of these radioactive materials, radiation takes place, okay, and because of that radiation heat is produced, okay, heat is produced. So now we have come to know, okay, how the center of the earth, this core and mantle, is getting heat, okay. Now we will study what is happening by that heat, how these tectonic plates are moving by that heat. Let me check the duration of the video. Okay, right. We will just a minute. Now we will study how this heat is responsible for the movement of crust over asthenosphere, and why this asthenosphere is in semi molten form. Earth is the rocks on which we stand, okay, right? They are floating on this asthenosphere, and the rocks which are here, okay, they have changed their form. They have become in semi-molten form because of very high temperature here. At 1400 degrees Celsius to 2000 degrees Celsius, one rock can melt, okay, right, can be brought into molten form. So that is why these rocks have come into semi molten form, okay. And on these semi molten rocks, the hard rocks keep flowing, okay, these hard rocks keep flowing, and these hard rocks have been divided into various tectonic plates, okay, various tectonic plates. These tectonic plates keep moving, okay, this crust keep moving towards each other, away from each other, and slide passing each other, right. That is the tectonic movement, towards each other, converging movement, away from each other, diverging movement, and slide passing each other, right. Now, how these tectonic plates move. Okay, we know that the rocks are in molten form, but still why these are moving, why these plates are moving, why can't they stay there, okay, just like that only, huh? There should be some force in order to bring movement in these layers, right? So that force is actually being generated by the convectional current. Now what is convectional current? I will tell you by very common example. Like suppose if you must have boiled water, okay, you must have boiled water. So when you boil water, then what happens? Suppose this is fire, okay, these are woods. Okay, suppose these are the woods and this is fire and water is boiling here, right? So if you have boiled water, then you see that, okay, the water molecules of water from the surface here, right, they go upside and then they come downside and they keep moving doing that, okay. Or you can do one thing, take small pieces of paper, okay, red paper, red or you can green, okay, small pieces of paper, put inside that, okay, inside the speaker. Then after that you will find that, okay, those papers are moving in this direction, in this way. First the paper which was settled down here moves upside like this, and then after reaching here then come downside this way, right? And the molecules of water also moves in this way, they come upside, okay, and then come downside this way. Means the molecules which were getting heated at the surface, first the surface of this beaker will become very hot, okay, and this heat energy will be experienced by this molecule, and this molecule will get energized and start moving upside, okay, till here, getting or not? When it will reach upside, right, it will come into the contact of cold water here, cold portion of water, then what will happen, it will lose its energy, right, and after that it will again